Hello, my name is Nikolai. I am an electrical engineering student of Aarhus University of Denmark. I am currently working on a semester project which will be a open source airship controller for use in reconnaissance and environmental use. And we decided to keep this project open source because it is meant for more or less humanitarian reasons and for the best of our nature. Therefore, I will be making this video blog. It's the first time I'm trying this stuff, where I will try to explain the different procedures and the different design considerations and slowly update you on the progress of the product. At some point when I'm going to get some time, I'm going to create a website where all the source code and all the information will be posted. Until then, there will just be these things, these video blogs. Yeah, well, I hope you enjoyed it. Alright, so the principal idea of this system is to build a airship and a controller for it. For people who don't know what an airship is, it is basically one of these sausages that were used under Second World War and a little before that, and now we use them for commercial usage and a little bit transportation for fun. But it hasn't really become a major system nowadays, even though it has a bunch of really interesting benefits. I'll come into those. But yeah, so basically a airship is a big balloon containing some kind of a gas that is lighter than air. Usually helium or hydrogen is used in this case. The problem about hydrogen is that it is explosive, and if you go to YouTube and write Hindenburg, you will find out a very dramatic way how that can affect the airship. And helium is the best choice. The problem is that it's really expensive right now, since it's a noble gas and we can't produce any of it. However, if a system is made relatively smart, you can avoid, if you tend to use helium, for example, if you make a really smart system, you can avoid venting any helium, and that's what we're going to try to do. However, this system will be built with brushless motors, so no sparks should be flying, so it should be relatively safe to use hydrogen as well. The whole idea of this system is that it should be used in reconnaissance areas or as an environmental aid. For example, if a town has been laid down due to some earthquake or whatever, these things can be sent up and survey and monitor the area to see which ways that you could take a convoy with help and stuff like that. In an environmental case, is that, for example, in Denmark, where I live, there is this agreement that Denmark has to spend a certain amount of resources on flying over environmentally sensitive areas, to especially harbor areas, to see if there is any oil leaks from ships and so on. And the economy spent on this is tremendous. You often use fighter jets for it, which is insanely expensive. This system will be able to supply a full and really reliable way to monitor environmental system for up to 12 hours, with basically a minimum cost and no environmental damage whatsoever, because it's completely electrical. Yeah, so the idea with this system is that this airship has to be able to be moved in 3 positions, or in 3 degrees of freedom. That is in the X, Y, and Z direction. And to be doing this, you can move in the X and Y direction. So let's say that this is the X direction, and this is the Y direction, this is the Z direction. So you can move in the X direction by propelling the motors in different speeds. That's fine, we understand that. We can be moving in the Y direction by changing the speed on the motors, and thereby twisting the ship to move sideways and to turn, basically. That's not a problem either. However, the challenge is to make this thing go up and down efficiently and without venting any gases. And for that we have developed a really interesting system. Instead of venting and applying more helium or hydrogen, the system will be made in such a way that the inside of the ship will contain bags of hydrogen. I'm really bad at drawing this apparently. Okay, let's say we have different bags of hydrogen in the system. So these things will contain the hydrogen or helium and makes the system buoyant. However, in the center there will be another bag, and this bag will be connected to a pump, and by inflating and deflating the center bag you will thereby make the gas here more dense, and by that reducing the buoyancy of the system. So by blowing in more air in the center bag, you'll reduce the buoyancy and the ship goes down. And then by having a solenoid which will open for this bag to the external system, the pressure will decrease in the bag and the airship will move up. That is the basic concept of how we're gonna try to move this thing around. But if it doesn't know where to move or how to move, this thing is worthless. So therefore, we'll be incorporating this system with a GPS control, GSM, thereby having a full coverage of, a full coverage, radio coverage all over the place. This thing might be an interesting issue if you're doing this abroad for reconnaissance missions. We'll look into that. And then an array of sensors. The most important sensors in this case is going to be a magnetometer. A magnetometer is basically a sensor that is a digital compass. So it will always know in which direction is the magnetic north. And thereby you can guide yourself to any kind of position. And we're going to need the GPS in order for us to know where we are and in which position we are interested to move in. The whole idea of this project is going to be that you will enter a GPS coordinate somehow, either by text message or SD card or something. We'll figure that out. And the ship will fly to the position of interest. Do some reconnaissance there. Look with its camera, which is going to be down here somewhere, and fly back after a while. The design team has proposed, the design team behind the physical airship has proposed that it's going to be 2 by 10 meters long, so it's going to be relatively large. But with this size, we can carry quite a lot of batteries with us, making us able to have an air time of about 12 hours. In the future videos, I will be covering the electrical development of this system, all the different sensors we're going to be using, all the power management, and all the control systems. In the end, the idea is that this controller will be completely open source. Anybody can use it for whatever they want to use it for. The only interest is that the name of the developers of the system, of the original system, has to be listed somewhere in the documentation or on the PCB. There is different systems out there that is doing somehow the same. However, they are meant for quadcopters and helicopters. There has not been made any open source blimp system so far as I have found out. If you know about any, please let me know. Yeah. And as far as I'm going to be developing this, if there's going to be any questions, any ideas, or any critiques, please let me know. This is a collaborated project, so the more people that contribute, the better result we'll get. Thank you very much. And by the way, I am no wizard when it comes to naming things. So if you can find a better name than Airship Controller, maybe there's something a little bit more original, please let me know. Then I'll put that into the consideration.